Good morning. Let us study today types of groups. There are three types of groups: abelian group, non-abelian group, cyclic group, also abelian, it obeys abelian, and subgroup. There are three types of groups, as I said earlier. One is abelian, it obeys commutative relation A cross B equal to B cross A. If the symmetry elements does not obey, the symmetry elements A and B does not obey commutative relation, then the group is called non-abelian. The third one is cyclic group, also obeys abelian. What is called abelian group? In some of the groups, the symmetry operations or symmetry elements present in the point group are commutative with each other, or symmetry elements commute with each other. For example, A and B are symmetry elements. They commute with each other, that is A cross B equal to B cross A. For example, C2V in water molecule, every element, every symmetry element commutes with other elements. Therefore, the number of classes is also called number of irreducible representations is equal to the order of the group. For example, C2V point group, the order of the group is equal to the total number of symmetry operations in the point group. E sigma V prime sigma V W prime and C2. So the number of irreducible representation, that is classes, equal to 4 for abelian point. Let us see what are called non-abelian point groups. Non-abelian groups, in most of the point groups, the symmetry elements operations do not commute with each other. It is A cross B not equal to B cross A. For example, ammonia molecule C3V point group, every symmetry element does not commute with the other elements. So this is just opposite of abelian group point group. So the number of classes, that is number of irreducible representation, is not equal to the total number of symmetry operations of the molecule. For example, C3V ammonia molecule H equal to 6, there are 6 symmetry operations, but the number of classes or irreducible representation equal to 6. The third type of group is called cyclic group. What are called cyclic groups? In this group, all the elements are generated from one single symmetry element. For example, A is one of the symmetry element. All the elements are generated from A. Let us see, for example, A square, A cube, A power 4, A power n. They form the symmetry elements. Okay. And A power n is equal to identity element. What is called a subgroup? Subgroup is a group actually within a group. You will understand here. For example, G equal to, this is a group. G is a group consisting of symmetry elements, identity element A, B, C, D, E, F, etc. The symmetry elements or operations. Now, subgroup equal to a subset of E, A, B, E, F. These elements form a group obeying the properties of the group called subgroup. Or in other words, if any subset of elements of the group satisfied or obeyed the properties of groups, then these subset of elements form a group called subgroup. Every subgroup must include the identity element operation. Show that or prove that C2V point group is abelian point group, whereas C3V is non-abelian point group. For example, C2V water molecule belongs to abelian group. Let us prove this, let us show this. Let us consider a water molecule and two operations, two symmetry elements or two symmetry operations, C2 passing through this and sigma V prime plane or sigma XY plane. I have shown here. Let us first carry out C2 symmetry operation. On C2, on rotating the molecule about this C2 axis, and this will come here and B will come here. A will come here and B will come here. Okay. Next, it is operated with the sigma V prime plane, that is in this plane. Therefore, A will come here, B will come here. We will get this resulting configuration, new configuration. Similarly, let us operate in reverse direction. A into B equal to B into A. So, sigma V prime is first carried out. This is the plane. Therefore, this will come here. This will come here. And next C2 operation is carried out. On C2 operation, it is same as sigma V prime only. So this will come here. This will come here around rotation. Now look at the two new configurations obtained by the commutative rule. Therefore, they are same, one and the same. Therefore, C2 sigma V prime equal to sigma V prime into. Let us show C3V is non-abelian point group. For example, this C31 and sigma V prime, these two symmetry operations do not commute with each other. They are not commutative. See, C31 not equal. Let us show this by taking ammonia molecule as an example. Let us first operate with the C31 symmetry operation. So you will get see there are two I have shown here these two symmetry operations, symmetry elements, C3 passing through nitrogen. This is a pyramidal molecule. This is sigma V prime passing through NH, passing through NH. Okay, let us first operate with the C31. Therefore, on rotating C3 will come here and 1 will come here and 2 will come here. Okay. And next, let us operate with sigma V prime. Sigma V prime. Therefore, this atom, sigma V prime, this atom is unchanged. Sigma V, this atom is unchanged. Therefore, it will be, this will be interchanged 1 and 2. Let us, similarly, a new configuration is obtained. Similarly, let us operate with the sigma V prime first. Okay, and then C31. Similarly, the two configurations are obtained. They are not equal in this case, whereas in abelian groups, the two are equal. They are commutative with each other. Here, the two are not equal because the two symmetry operations are non-commutative.